Hello everyone. Today we're gonna learn about Gauss law. So let's not waste much time and get into it. So what's Gauss law? Gauss law is a fundamental principle in electromagnetism that relates the distribution of electric charges to the resulting electric field. Mathematically, it is expressed as del E dot dA, which is equal to Q enclosed by epsilon naught. So the enclosed charge in the surface divided by the permittivity gives us the equation that is a closed integral of E dot dA. So E is the electric field, dA is the vector representing an infinitesimal area on a closed surface S. Q is the charge enclosed within the surface S, and as I said, epsilon naught is the vacuum permittivity, a constant. One more thing, you can see that the magnetic lines exit through the north pole and enter through the south pole. So you should remember always that magnetic lines travel from north to south outside the magnet, and inside the magnets it's from south to north. So let us see the proof of Gauss law. So consider a point charge Q located in a homogeneous isotropic medium of permittivity epsilon. At any point, the electric field intensity at a distance r from the charge is E equal to Q by 4 pi epsilon naught. I'm sorry for that. So, as I said, E is equal to Q by 4 pi epsilon r square. And the flux density is given as T is equal to epsilon naught T, which is Q by 4 pi epsilon naught r square. 4 pi r square, sorry. It's 4 pi r square. So the flux through area dA, d phi is equal to d into dA dot cos theta, where theta is the angle between d and the normal to dA. So dA dot cos theta is equal to r square du. Now, dA cos theta is the projection of dA that is normal to the radius vector. Solid angle is given by phi equal to closed S d phi, which is equal to closed integral of dA dot cos theta, which is closed integral of S d square d, which is equal to q by 4 pi closed integral of d phi. So d phi is the solid angle subtended at q by the elementary surface area dA. So the total displacement of flux through the entire surface area is phi, which is equal to closed integral of d dot d, which is equal to q. So the total electric flux through the entire surface is, this is the integral form of Gauss theorem, and hence this theorem is proved. Let us go through the applications of Gauss law. So Gauss law is used in various applications, including electrostatics, like calculating electric fields around symmetric charge distributions, capacitance, determining the electric field and potential difference in capacitors, analyzing electric fields within and around insulating and conducting materials, gravitational fields. By analogy, it is also applied to gravitational fields in astrophysics. So this is the capacitance. This is for conductors and insulators. And finally, we have gravitational fields. I'm sorry. So electric field due to line charge. So the electric field of a line charge can be found by superposing the point charge field of infinitesimal charge elements. To find the electric intensity at point P at a perpendicular distance r from the rod, let us consider a circular closed cylinder of radius r and length L with an infinitely long line of charge as its axis. So you can see this is the electric field due to a line charge, that is N is the line charge. Therefore, according to Gauss law, you can see the equation. So where 2 pi RL is the curved surface area of the cylinder, therefore del E is equal to Q pi epsilon naught, charge enclosed in cylinder, is equal to line charge density into length L, that is del L, where E is equal to 2 pi RL into L into del by epsilon naught, or E is equal to del by 2 pi epsilon naught R. Here, del is the line charge density coefficient. Advantages is in disadvantages. Advantages: simplifies calculations, fundamental insight, wide applicability. Disadvantages: limited to symmetry, complexity in asymmetry, and requires enclosed charges. So that's it for this video. Thank you.